This is LeetCode number 3202. Find the maximum length of valid subsequence 2. You are given an integer array nums and a positive integer k. A subsequence sub of nums with length x is called valid if it satisfies the following condition. Return the length of longest valid subsequence of nums. So if our subsequence is sub, so it should satisfy the condition that sub 0 plus sub 1 remainder with k equals to sub 1 plus sub 2 remainder with k equals to up to so on up to n minus 1 and n minus 2's sum whose remainder is with k. So this is the condition that we need to conform to. So while seeing this question, what we get into mind that this is a DP question. How? Suppose if we have a array 1 2 3 4 5. In this array, if I want that at any point, if I'm at this point, if I want that at this point with a remainder, suppose k or I, suppose we are at index I and we got a remainder t of 3 with others, maybe and following j numbers. So for this condition there should be a value that should exist. How? It's such that we need to have a double for loop in this case. Suppose our array is 1 2 3 4 5 and k be anything. We don't know, k be anything. So if we start from here, we see that we cannot go further. Okay, so now at this point what we do is that all the remainders from this point would have count of 0. Count of 0 for all remainders. So we should not touch this point. Now we are at this. So for this point, what this point says, that if I am at point n minus 2, how many remainders can I form with further numbers or further elements? So only one number is ahead of 4, which is 5. So if we do the plus, it would be 9 and the remainder with k would be the remainder. So now what we can do here is that if we take the remainder to be n k, so if this thing exists for n, we just need to add 1 to put it for n minus 1th index. Take it n minus 1, take it n minus 2. So n percent k. So this is the condition that we need in this question. Suppose we go further down. Let's just try run it. So for dp 3 0 1 2 3 4, for dp3 and sum is 9 and the remainder with 2 is 1. So dp3 1 equals to dp4 1 plus 1. which would be, it would be 0 plus 1 equals to 1. So we only have one value for 4. Now we go on 3. We see that dp of 3 can go with anyone. It can go with 4, it can go with 5, the next as a next element. So if we go with 4, we would have a remainder 1, because 4 plus 3 7, and remainder with 2 is 1. So dp31 equals to dp4, sorry, dp21, the index is 2, equals to dp3 1 plus 1. So if we are standing at 3, we know for sure if we are at 3, we can go to 4 and we can find this much amount of further numbers. So for dp21 it would be, dp31 we found out that it was 1, so it would be 2. Okay, so we go for 3 with 5. So dp of 3 with 0, because 3 plus 5 8, and it remainder with 2 0. It would be equaling to dp of 5 0 plus 1. So it would be 1, because this is 0. So like this we can do it for the first index. For dp 1 we can go with 3, we can go with 4, we can go with 5. So for dp 1, and if we iterate from 2 to 4, we can find that first it will have a remainder 1, 2 plus 3 5, divided by 2 remainder 1, then it will have remainder 0, then again 1. So for the first one it will have the value of 2 plus 1, because dp of 2 1 equals to 2, which we have found out previously. So like this we can find out for the second index, and so on we can find out for first index all the values. And while we do it, we always keep in mind that we need to find the maximum value. When we iterate on each index, we will make sure that we will check whether is it the maximum value that we have found out or not. So how would we go about it? We just do 2 for loops. One starts from I equals to n minus 1, I greater than equals to 0, plus I plus plus. And other for loop would go from I j equals I plus 1, I is less than n, it would be j I minus minus, I minus minus, and I plus plus. In this case, what we will do, we will just do dp of the current number, which is I, and the remainder which we will find how nums of I plus nums of j whole remainder with k equals to remainder r. So dp ir equals to dp of j r plus 1, and we need to make sure that it's always maximum, because we can have lots of number, and for lots of number we can have multiple remainders. We can have same remainders but with different frequencies for the dp. So we will do dp of I r. We will put this in math.max. So So next what we will do, we will make sure that for this number we will put a temp. We will initiate it at 0 here always after the first for loop, and then when it comes here it will check math.max of temp and the current dp, I and r. And finally what we will do, we will do dp of answer equals to math.max of dp, not dp, math.max of answer and temp. So it will give us the maximum value which we can achieve. Since we are starting from 0, we are taking all of them with 0, we will just do answer plus 1 finally, wherein we will have the final answer. So here is the code for that. We have took a integer nums.length n equals to nums.length dp. We have took n into k, answer 0, t and temp, other two variables. We have initiated for loop, and inside that for loop another for loop starting from the next index of the current ith. We will initiate temp equals to 0 for every time we will go into the second inside loop, and finally when we move out of the inside loop, we will do answer equals to math.max of answer and temp, and finally we will return answer plus 1. Let's run it. It's been submitted.